My name is Christiana Albert. I'm a PhD student at ETH Zurich.
I'm Fulvio Canonico. I am the R&D manager of Buzzi, cement producer.
Hi, I'm Hong Wong. I'm from Imperial College London, where I'm a professor of concrete materials.
So basically, what happens is that cement industry emits a lot of CO2, and we need to reduce the CO2 emissions. We can do that by having low clinker cements, but one consequence of these cements is that usually the concretes made with them carbonate faster because they have a lower calcium hydroxide content and more like chemical properties. Usually carbonation is associated directly with corrosion because during carbonation you have a decrease in the pH of concrete, and in this new low pH, the steel might no longer be passivated, so it can start corroding at high rates and leading to the deterioration of the structure. One thing that we want to study more in our project is carbonation-induced corrosion, and instead of just assuming that carbonation will lead to a high corrosion rate, we want to understand in which conditions. So we are trying to understand these separately and get to a mechanism-based model where we can predict corrosion rates as a function of the low clinker cements and these properties.
Yes, I think this is a very innovative approach because, we have a lot of standard in Europe, in the world, but guideline for application of concrete is not standardized. And so this is a good way, a good approach to start maybe to look at how we can modify guideline regarding new way of construction with low clinker cement, with a strong approach to durability. Of course, most of the research we have done so far look at the durability performance of the concrete in terms of carbonation, in terms of resistance to chloride ingress. And so looking at the steel which is embedded in the concrete is very important because we can really see how potential damage may occur in the future use of this cement, and we know that corrosion is one of the main aspects of the durability of a structure, and so it's very important.
A lot of data, very novel, very interesting data that will help us to understand, how these systems carbonate and whether or not they corrode when they carbonate. Obviously, that's going to lead to sort of new fundamental understanding, but I suspect, I'm quite sure we won't be able to answer all the fundamental questions. The data that we collect and the understanding that we'll gain will feed into some of these standards that we are currently using in the industry to help to sort of promote the use of these low carbon cements in the future.
Will be also for the industry an important way to understand how we can produce such cement in the best way in order to be more durable. So there is also the chance to modify the recipe in order to meet the requirement of durability and steel corrosion. So this is very important for the industry.
This is hugely important because, in universities and academia, we can do research in the lab, we can dream out of projects, research problems, and we can do all sorts of, very accurate and fundamental measurements. But we need to ensure that the results that we're getting, the findings that we are delivering, was going to be industrially relevant. And I think this is where GCCA is hugely important because, we're all trying to solve this major, global pressing issue, and this needs this collaborative and collective approach to be able to deliver this this ambition of net zero cement and net zero concrete. So within the GCCA, what I really enjoy is the open nature, the collaborative and the sort of discussions that we have to define the important research questions, agree on the approach that we handle to deliver the research and the findings, and to then translate that to practical applications. I think that's no other sort of organizations that I'm aware of that has such a huge amount of collaboration between industry and academic partners.